Good day, everyone. Today I will present a video tutorial about this Excel program. It is all about the actually loaded tide column and the actually loaded spiral column. So first, let us discuss this actually loaded tide column. So here we have to input the dead load given in the problem, also the live load, the FC prime, Fy, and the diameter of main bars, also the diameter of ties. If these are not given, this diameter, so we have to assume values. And also we have to input the steel ratio given in the problem. And if not given pa rin yung steel ratio, so we have some standards to follow. So we have the ideal value of steel ratio ranging from 0.015 to 0.030. So between that range, we can assume our steel ratio. So nandun yun sa code. So kayo na yung bahala yung mag-review. And for section to be smallest, so take note na natin, yung steel ratio dapat dyan is 0.60. So ayan. Then, so automatic na tong program. It will solve the PU actual, the area gross of the concrete column. Then we have the dimension. Yung sin square ba ito, so yung dimension is yung length and width is equal, di ba? So ayan. Then we also have to compute for steel bars and the number of bars. So mag ano lang natin yan. Say lang natin yung value pag naka-decimal, so kailangan natin whole number. So ayan, then ma-solve din natin yung, then we have to check also the capacity. So if yung seal ratio natin is greater than 0.01, so okay siya. Then pag hindi naman, so adjust natin yung diameter sizes. Then for PU actual naman, pag check natin yung capacity, if greater siya ng PU actual natin dito, ang value dito is greater dito, so it means okay siya. Then same goes pag hindi, so adjust natin yung size. Then we have to calculate the spacing of the lateral ties. So if if less than siya ng 32, if yung main diameter is less than or equal to 32 mm, so automatic 10 mm diameter yung gagamitin natin sa lateral ties. And if greater naman nung 32 mm yung main bars, so yung diameter ng ties natin is 12 mm. Then with that, masosolve na natin yung spacing lateral ties. It could be first yung 16 ng diameter bars, so 16 times diameter bar. Then we also have 48 times diameter of ties, and lastly we have the yung least dimension of column. So dito yan, so, dito ayan. So I have prepared here two codes for 2001 and 2015. So let's try to solve some problems regarding this actually loaded tide columns. So let me show you a problem. So na ba yan? Dito. Ito. So problem, design a square tide column is to support an actual dead load of 575 kN and actual live load of 770 kN. Assume Fc prime is equal to 27.6 megapascal and Fy is equal to 414 megapascal. Use 28 mm main bars and 10 mm main bars. So hindi na kailangan mag-assume ng mga diameter, di ba? Kasi given siya ng problem. Ang hindi given ng problem is that yung yung seal ratio. So between ideal value, di ba, 0.015 to 0.03, so assume natin na 0.02 yung seal ratio natin dyan. Sige, try natin input. So we have 575 sa dito sa dead load, 575, and dito 770. Dito, FC prime 27.6. FI natin 414. Check lang natin to mamaya. Diameter of mean bars 28 yan, di ba? Then diameter of ties, that is 10 mm. And seal ratio, assume natin na 0.02. So ayan. Check lang natin muna. 575, 770, 27.6, 414, 10, 28. So ayan, okay na yata to. So we have here 2 P actual natin na nakuha is 2114 kilonewton. Yung area gross ito 120,719,649. Ayan, makikita natin yung mga values niya. Then we have the dimension of the column. That's 347.477 by 347.477. So say ano na lang natin yan. Mas malaki yan dapat. So we have 350. Say 350 mm tayo dyan. And for area of steel, so we have 2414.393 mm squared. And number of bars 3.921. So say 4 bars yan. Then makikita natin dito na yung pag-check sa capacity, yung steel ratio natin is greater than 0.01. So that's good. It's okay. And yung PU naman 2148. So it's greater than PU actual. Makikita natin 2148. Yung PU actual natin is 2114. So okay din yan. Then dito naman use 10 mm diameter kasi ito use 10 mm din kasi yung diameter ng mean bars natin is less than nung 32 mm. So 28 yan. So we have our DT, that's 10 mm. And pinakita naman dito, so verify lang. So yung first spacing na nakuha natin is 448 and yung second 480 and yung last is 350. So yung mag-govern is yung mas maliit space. So that is 350 mm. Therefore yung cross section natin is yung 350 mm by 350 mm, diba? Kasi square yan siya. Then vertical bars naman natin, that would be ilan yung number of bars natin? 4 nung main bar, diameter main bar 28 mm, diba? 28 mm bars. And then yung sa ties naman natin, that's 10 mm diameter yan. At yung distance natin nakukuha natin yung S 350 mm on center yan siya, on center. So ayan yung conclusion natin. And for ano naman 2010-2015 NECP code, so we have here the values. So yung dimension natin na nakuha 343.799. So say ilan ba? 350 pa rin. 345 lang natin dun sa mas malapit lang, 345. Ayan. So 3.839 yung number of bars natin, so say 4. So ito lang talaga yung kailangan natin take note sa program na to. And that would give us the steel ratio of this one, which is greater than 0.01. So that's good. And also the PU 1952.2 is greater than PU actual na 1922. So good din yan. Then same, use 10 mm kasi 28 yung diameter ng main bar natin. And that would give us the value of S 488, 480, 345 mm. So yung mag-govern is 345 mm. Therefore, yung cross section na gagamitin is 345 mm by 345 mm. And yung vertical bar naman natin is 4 nung 28 diameter bar. Yan. Then yung sa lateral ties naman natin, di ba 10 mm yan? 10 mm diameter at 345, di ba? S natin is 345 mm on center. So ayan. So I hope klaro tong program na ito. So take note lang natin ulit yung input natin na value, dead load, live load, FC prime, FY, and diameter of bars and ties. Also the steel ratio. Ayan. So proceed tayo sa actually loaded spiral column. So same lang input natin. Dito is nalagdagan lang siya ng FYH. That's for yung sa steel na yan siya. And yung steel covering din natin kasi spiral na siya. So meron yan siyang diameter ng core at yung diameter ng outside. So same lang talaga. Same lang yung natin input. So try na natin solve ng problem. So here, design a round spiral column to support an actual dead load of 900 kN and an actual a live load of 1,300 kN. Assume that 3% longitudinal steel is desired. Fc prime is equal to 27.6 megapascal and Fy is equal to 414 megapascal. Use 25 mm main reinforcement. Determine also the minimum spacing of 10 mm spiral, and FYH natin is 27.5 megapascal with 30 mm steel covering. So, ayan, input natin to. So, we have dead 900 and 1,300. That's 900, 1,300. FC prime 27, 7.6. Ayan. And yung FY is 414. Itong FYH, alam nyo siya? FYH natin. 27.5 or 275 pala. 275. So that's 270 sana yan. So that's 275. 275. Diameter ng main bar 25, yun siya. Diameter ng spirals 10. Steel ratio is 3%, so that's 0.03. Ayan, then yung steel covering, that is 30 mm. Tama ba? Check muna natin. So, ayan. So, okay na to. Pinatang input na mga values. So, punta tayo dito sa for concrete column. So, makikita natin na nakuha natin yung PU actual, area gross, ito, and diameter of column. So, ito, sa diameter of column yung D, so ito yung outside diameter. So, that's 443.869. So, say 445. Ayan. So, yan, yung outside area natin ito. And ito naman yung for steel. So, ito yung area ng steel. And yung number of steel bars na gagamitin is 9.5 daw. So, say 10 natin yan. And for capacity, check natin yung capacity. So, same lang kanina sa tide. So, if greater than 0.01, so okay. Okay ito dito. And dito rin, okay din kasi mas malaki yung PU na nakuha. So, ayan. Then, so we have also here for the design of our spiral. So, we have core diameter. That is 385 mm. And core area natin ito, 116,415.643 mm squared. And yung PS mean natin, that is 0.01517. So, ayan. No problem na dito kasi automatic na to sa program solve. So, dito naman, spacing of spiral. So, we have area of spirals. That is pi over 4 lang yan nung diameter nung spiral natin. It's 10. So, ayan, ito ano yung makuha na value. Then, yung S natin dyan. So, that's 52.380 mm. So, say, ano natin, mas malit na spacing, mas better kasi. So, say, 50 natin yan. So, say 50. So, ayan. Meron tayong S clear na 40 mm. Then, yung standard dito is, kailangan yung S clear natin is, is greater than or equal to 25 mm, but less than 75 mm. So, ito, in between siya. So, okay yan. Okay dyan. Then, dito naman yung 50 mm natin. So, same pa rin. That's greater than 25, less than 75. And also, it is less than no 1/6 ng core diameter. So, ayan, okay na yun siya. So, therefore, yung cross section natin is, we have yung diameter ng outside, that is, ilan yan siya? That is That is 345 yata yan. Check natin. 345. 445 pala. 445. That's 445 mm diameter. Yan. Yung vertical bar naman natin, that's, ano yun, ilang bars yun? 10. That is 10. Nung diameter bars natin, 28 mm. Diameter bars. And spirals natin, di ba 10 mm yun? So 10 mm diameter at yung S natin 50 at 50 mm on center. So ayan. So I hope klaro yan dyan. So that's for 2001. For 2015 naman and 2010 NCP code. So ito dito. So meron tayong P actual. So tingnan na natin itong mga values na to. So sa dimension tayo, we have 423.579. So that's say 425. So ayan. So meron tayong number of bars na 8.67. So say 9 natin dyan. Say 9 bars. So kikita natin na yung still ratio natin is okay siya kasi ano siya, greater than 0.01, and also yung PU natin, that's 322. So greater siya nung 3160 ito, PU actual. So ayan. Then for design of spiral, meron tayong nakuha na core diameter, that's 365. And we also have this core area and yung PS min natin. So ayun yung mga values. So S natin is 52.097. So say dapat mas maliit siya, so 50. Kasi mas maliit mas better. So S carrier natin is 40. So same requirement, that 40 is greater than 25 but less than 75. Then yung itong S natin is greater than 25, less than 75, and also less than 1/6 nung natin core diameter. So therefore, okay na itong design natin dito. So yung cross section natin na gagamitin is ilan siya? 425, tama ba? So that's 425. Okay. So that's 425 mm diameter. Oh, wait. Doon sa diameter yun siya. Ayan. Mali. Ayan. So, it's 425 mm diameter. And for vertical bars natin, so you have 9 bars. Yeah, number of bars natin is 9. 9, 28, 28 mm diameter bars. And we have for spiral, diameter ng spiral is 10 mm. That's 10 mm diameter. At yung S natin distance, 50 mm on center. So ayan. So I hope makakatulong itong program ito sa future solving ng mga actually loaded tied and actually loaded spiral column. So ayan, thank you and God bless everyone.